So I'm a research scientist at Environment Climate Change Canada in the Meteorological Research Division. And so my area of research focuses on remote sensing. So I use instruments usually on the ground to take observations of the atmosphere, using instruments like radar, LiDAR, and different instruments that can sense at great distances. Currently, I've switched a little bit to meteorology. So we're looking at severe weather, extreme weather, high impact weather, think of flooding and blizzards in the Arctic, using instruments from a number of different sites. For instance, in Iqaluit, we were in Whitehorse and a couple other locations. The Arctic is incredibly different from what most people are used to in Canada. It's typically where I've worked is in, they call it the Arctic tundra. So it's, for instance, there's no trees because you're north of the tree line. It's very small vegetation. It's mud in the summer, and then it's frozen snow drifts in for the rest of the year. So it's incredibly different when you're out there. Obviously, it can get very cold, but people don't realize it can get very warm in the summer too. You know, you can reach temperatures around 20 degrees or so. So you're dealing with extremes, extreme cold in the winter, extreme some hot summer temperatures. The other extreme you're dealing with in the Arctic is the sun. So in the wintertime, you can get polar night. So the sun just doesn't come up and you're in darkness 24/7. And in the summertime, you get the polar day, which means the sun is always up and you don't get darkness. And that can really mess with your psyche sometimes, just 24 hours of sunlight or 24 hours of darkness. There's a number of reasons that can point to why the Arctic's warming faster than other places. One of the primary drivers is there's something called Arctic amplification, which is to say that a lot of the changes that are occurring in the Arctic are happening the fastest. And then those changes, for instance, if you look at melting sea ice, that's affecting the albedo, so you get a positive feedback loop. So one change is affecting other processes that accelerate the change, and then you end up in this loop where it happens faster in the Arctic. So that's why a lot of the signals for climate change that we're measuring are first being detected in the Arctic, or the magnitudes are the greatest in the Arctic compared to other locations. There's a number of consequences for a warming Arctic, a lot of which we're starting to see, they're already happening, basically. One example is if we look at things like atmospheric rivers. So these are events where you have a lot of moisture in the atmosphere. Typically they happen in the West Coast, so places like Vancouver. Well, we're measuring them now, they're happening in the Arctic. And a good example is recently there was flooding, like unprecedented rainfall in Iqaluit, in northern communities, where they're not at all designed for the infrastructure to handle this much rain, because that's not what typically happens up there. And there's a number of other consequences to deal with, the loss of sea ice and how that affects the local communities, their hunting patterns, and things like search and rescue, because you have such changing weather events and changing conditions of high impact weather. It really impacts the people that are living up there or that are traveling through there. Think of shipping routes and the flights that are occurring in the Arctic. Related to extreme weather events, one is the example I gave with atmospheric rivers. So we use satellite observations and ground-based observations to look at water vapor and winds. So what we're looking at is a flux. Do we have a sudden flux of wind and water vapor? It's called integrated vapor transport. And that can be something that can be quite alarming in terms of the rain and the precip that can occur. Other things that we've really focused on in the Arctic are things like sea ice loss or melt. Blizzards is a kind of an obvious one. So we're looking at not just detecting blizzards, but also trying to improve our forecasts of blizzards to give people warnings for, hey, is it safe to go out on the ice? Is it not safe to go out on the ice? Is it safe for a plane to come in, or is it not safe? So a lot of these products we combine our observations from our instruments with different processing techniques. One example is using machine learning and AI to try to improve our forecasts. And one of the projects that I'm involved in is looking at what new technologies exist out there that can improve our observing capabilities. So if we want to test some of these new technologies, the best place to do that is the Arctic, because they're going to get beaten up and they're going to see such an extreme change in terms of, the coldest temperatures, the hottest temperatures. You go from almost no water vapor to lots of water vapor. So if you want to test these instruments and look at, how well do they perform, what are their applications, the Arctic is an excellent testing ground. And then from those lessons learned, we can apply them to the rest of Canada. So my research really focuses on meteorology, so the weather, and how is it changing as a result of that? And what are some of the new concerns in terms of high impact weather? One of the things we're looking at is how the storm systems that are hitting the Arctic are increasing in intensity and severity. And this is expected to increase over time. It's not a sort of a blip. We're expecting that this is just going to keep happening. And the magnitudes of these changes are going to be much more severe. If you want to know what's going to happen here, what's happening in the Arctic first. So you take your measurements in the Arctic first, you understand what's happening there, and then that's sort of our early warning system. It's going to happen, we're next, basically. The second aspect of that is a lot of our weather is interconnected with what's happening in the Arctic. So 10 years ago, no one heard of the polar vortex. And now it's all over the media because you have these changing weather events where the polar vortex is now influencing weather all the way down as far as Texas. And that it rarely happened before. And so there's an immediate implication for what's happening in the Arctic is influencing the southern US. Other researchers, colleagues of mine who are sort of focused on the climate research or the sea ice research, they're looking at different processes. So there's, cryosphere processes, sea ice processes. They're looking at, if we look at, for instance, the chemical composition of the atmosphere, we look at methane, for instance, that's increasing in the Arctic as we have permafrost thawing. Those are all different aspects, but these are all different pieces of the puzzle that when you put them all together, they tell sort of a cohesive story. One of the most important aspects of the research that I'm doing is how important it is to communicate, because we're all sort of guilty of kind of being trapped in our own sort of bubbles, be it social media or whatever's going on. And that has a number of effects. So a lot of people I talk to describe sort of this climate fatigue of, okay, things are getting worse and there's nothing we can do about it. And I understand where they're coming from, but there's a lot of positive news out there as well in terms of some new technology that's coming out or some advancements that are being made in terms of trying to fix some of these problems. So my advice would be, to communicate as much as you can, try to reach across the fence, get out of your bubble. It's so important to reach out to other people who, if they have a different opinion or they don't understand why this is an issue, well, there's no reason to get upset. Let's engage and let's talk about it. Let's understand where they're coming from, where we're coming from. I'd say that's number one. So engagement, communication, really try to genuinely understand where different people are coming from. Other than that, there's a number of issues a number of things you can do on the home front. I mean, the simplest thing is, some of these initiatives for lowering pollution or wildlife support for the Arctic, or just supporting the communities up in the Arctic who, it's really impacting the people who live there first. And there's a number of things you can go online and look at, what can we do to support the communities and the people that are living up there that might need this, the help, or to at least adapt some of the changing environments that are occurring.